Adding and subtracting rational expressions. Part 1. In this video, we'll add and subtract rational expressions that already have common denominators, and we'll learn how to simplify the numerators. We'll recall some methods for finding a least common denominator and writing equivalent fractions. And then we'll practice adding and subtracting rational expressions after we find the least common denominator. You know that to add or subtract fractions, they have to have the same denominator. And the same is true of rational expressions. We're going to start with some cases where that's already true. For example, these two rational expressions both have a denominator of 5. So I could just add them by adding the numerators and putting the result over 5. So I have x plus 4 plus 4x plus 1 in the numerator. X and 4x are like terms, so I can add them together. I get 5x. And 4 and 1 are like terms, and I can add them together and get 5. Before you finish, though, factor. I can factor a 5 out of the numerator, and that gives me x plus 1. Now the 5's can cancel, and the result is just x plus 1. In this example, we're subtracting rational expressions. We look at the denominators first and see that we already have a common denominator. So we're going to add the numerators and put them over the denominator. Now when I add the numerators or subtract, this minus sign applies to everything in the second numerator. So 2x minus 10 is added to negative x and negative 8, which is positive 8. That's a really tricky part of subtraction because the parentheses around the numerator are invisible. But the minus sign applies to both terms, so watch out for that. Now I'm going to simplify the numerator by adding like terms. I have 2x and minus x, and that's just 1x. And I have a minus 10 and a plus 8, and that gives me minus 2. So when I'm all done here, I have x minus 2 over x minus 5. You know you can't cancel the x's, no. So we're all done. Well, here's a complicated looking rational expression. But let's check the denominators. They match, so we're all set. Now, some observant people might be tempted to cancel. You see that there's an x plus 3 on the top here that matches this x plus 3 on the bottom. And there's an x minus 5 that matches the x minus 5. But the result of doing that canceling will be to eliminate the common denominator. If I cancel, I'll have denominators of x minus 5 and x plus 3 that don't match. So don't do that. Instead, let's write the common denominator and simplify the two numerators, putting them all together. So I'm going to have 2 times x plus 3 minus 3 times x minus 5 on the top. I'm going to distribute the 2 outside, and that'll give me 2x plus 6. And I'm going to distribute the minus 3 outside, and that'll give me minus 3x plus 15. Now I'll find my like terms. 2x minus 3x gives me a negative x. and plus 6 and plus 15 gives me plus 21. Now that's still over this common denominator, x minus 5 times x plus 3. So the final result is negative x plus 21 over x minus 5 times x plus 3. Let's add these two fractions with numbers and watch how we find the common denominator so we can use that method with rational expressions. So I have 7/15 plus 9/10, and I need to find a common denominator. I'm going to start by factoring the two denominators. When I factor 15, I get 5 times 3, and when I factor 10, I get 5 times 2. Now, I've put both the 5's in blue so that you can see that they match. To find a common denominator, I don't need to worry about the 5 because it's already in common. Now the first denominator has a 5 and a 3, but it doesn't have the 2 that's in the second denominator. So I'm giving it a 2, and I have to multiply by 2 over 2. That is, I have to multiply the numerator by 2 because 2 over 2 is equal to 1. And when I multiply a number by 1, I don't change its value. Now if I look at the first denominator compared to the second denominator again, I have a 3 in the first denominator that I don't have in the second. So I do the same process of multiplying by 3 over 3. That's going to give me a common denominator 2, 3, and 5. And the top, well, I've done 2 times 7 and 3 times 9. 2 times 7 is 14, and 3 times 9 is 27. So when I add those, I get 41. And on the bottom, I have 2 times 3 is 6, times 5 is 30. So this whole expression simplifies to 41 over 30. Now, it doesn't matter what kind of factors I start with. On the bottom here, I have red flour times blue flour, plus, and then on the bottom of the next fraction, pink flour times blue flour. It doesn't matter what the factors are, the whole denominator has to match. Since the first denominator has no pink flour, I multiply by pink flour over pink flour. And since the second denominator has no red flour, I multiply by red flour over red flour. For example, 2 times x plus 2 and 3 times x plus 2 are not common denominators. But all I need to do is multiply the first one by the thing in the second denominator that it doesn't have. And all I need to do is multiply the second one by the thing in the denominator that it doesn't have. Then I can simplify. The new denominator has all 3 factors, so it matches for both of them. The first numerator is 3 times 3, and the second numerator is 5 times 2. So when I get all done simplifying, the numerators are 9 plus 10, or 19, and the denominator is 2 times 3 times x plus 2. So 2 times 3 is 6. I have 6 times x plus 2 on the bottom. I can multiply it out or leave it. That's a nice thing about rational expressions. And I end up with 19 over 6x plus 12. So there we go. That's how to find a common denominator for rational expressions.